In this video, we're going to start looking at calculating percent composition. This might be the easiest calculation in the entire chapter. It just makes sense. Percent composition is the mass of a particular element divided by the mass of the entire compound. We multiply by 100 to make it a percentage. It just makes sense because a percent is like the part divided by the whole. And it's the exact same concept here. Now we do need the formula of the compound that we're studying. So in this case, if I want to know the percent composition of all elements in hexane, I might need to draw hexane. It might be the best way of getting the formula. Hex is the prefix for 6. A-N-E means single bonded. 4, 5, 6. 6 carbons all single bonded. Then we go around the outside and we add our hydrogen. 3, 4, 5, 6. Carbon always needs 4 bonds. So we'll fill them up. We'll count the hydrogens and we got our formula. Hexane should be, how about C6, H, 2, 4, 6, 8, 10, 12, 14. With an organic, which they are kind of sprinkled throughout second semester a little bit, the best way of getting the formula is really just to sketch it. Hexane, 6 carbons single bonded. Next order of business, we're going to need the molar mass. We're going to need the mass of the compound. I usually try to do that first. So in my calculator, I'm going to have carbon. Its mass is 12.01. There are 6. If I were just to kind of plug that in, it would give me 72.06 total grams of carbon. And then my hydrogen, 1.01. There are 14 for a total of 14.14 grams of hydrogen. We add this up and the total mass, 86.20 grams. The C6H14. Easy. We've done all of that in the past. You crushed it, right? So again, if you get the formula right, I have no doubt that you will get the molar mass correct. And you don't have to show me work for this. I do not need to see any of this work. Plug it in your calculator. Now this is what I do need to see. The percent composition part. Percent composition of all elements. So what if I want to do the percent carbon? Then we want the mass of carbon divided by mass of the compound. We want the total mass of all the carbon. So I really want to go back to this guy. There were 6 carbon, so I want the 72.06 grams of carbon, the total mass of carbon. We'll divide that by the total mass of the compound. 86.20 grams, C6H14. Plug it in, multiply by 100. And with these, you don't really have any lab data. So for sig figs, I would say maybe 2 decimal spots. 2 decimal spots should be plenty of precision. 83.60% carbon. Show me that. Show me the red stuff. Because then I know the formula that you used. Show me the formula, C6H14. Show me the mass. So if by chance you wrote the wrong formula, I can see if your mass is correct based on the formula you did right. And then I can also see that you used the right mass of carbon. Not the 12.01. We want the mass of all 6 carbons, the 72.06. Now from here, you've got 2 options on how to figure out the percent hydrogen. You could do something similar. You could say percent hydrogen is the total amount of hydrogen. There are 14.14 grams of hydrogen. The mass of the compound is 86.20 grams. C6 H14 times 100. And just out of curiosity, if I plug this in, I get exactly what I was expecting. I mean, these two together should give you 100%. So if you only have two elements in your compound, you could do like the percent carbon and then just subtract from 100 to get the hydrogen. Or in this case, if I really did plug them in, I know I did everything right if the two together add up to 100%. Show me the work in red. Then I have everything I need if you get the final answer wrong. I can kind of walk backwards and figure out where you made a mistake. So these really aren't too bad, are they? You do have to get the formula right. So if you get the formula right, you're probably in a good place. Let's try one more. Calculate the percent composition of all elements in cobalt 2 sulfate. So cobalt sulfate, cobalt 2 sulfate. That means the cobalt's charge is +2. Sulfate is SO4 -2. Ooh, I kind of like that. It's neutral. And again, have your periodic table, have your polyatomic ions handy because you'll need them to write the formulas. Now again, I don't need to see how you got the molar mass. Plug it in your calculator. So in this case, in my calculator, I'm going to go 1 times cobalt plus sulfur plus 4 times oxygen. And I get 154.99. Just plug it in. Show me this. Percent composition of all elements. Percent cobalt. There's only one cobalt. 58.93 grams. Divided by the mass of the compound. 154.99 grams of cobalt sulfate. Multiplied by 100 to make it a percent, and plug that in your calculator. So with like maybe 2 decimal spots, 38.02% cobalt. There's 1. Then we have to do it for at least one other element. So I could do percent sulfur. There's only one sulfur. 32.06 grams of sulfur. The compound is the 154.99 cobalt sulfate times 100 to get me a percent. Here I'm looking at maybe 20.69% sulfur. Cool. See, this isn't so bad, is it? Now you have a few options for the oxygen. You could do the percent composition very similar. My oxygen would be 4 times 16 for 64.00 grams oxygen. Divided by the compound, 154.99 cobalt sulfate times 100. And this gives me about 41.29% oxygen. So you could do the third calculation just as we did. Or you could add the first 2 and just subtract from 100 to get the oxygen. Either is totally acceptable. Like if I add all these together, I should be right around 100%. If by chance you're like 100.01 or 99.98 or something like that, it's probably just in how we rounded. But often, if you round to 2 decimal spots, it's enough precision that when you add them together, you're right at 100%. So for showing work, show me this. Show me what's in red. I have everything I need in order to figure out where you might have made a mistake. And definitely put these labels in too. This is mass of sulfur divided by mass of the cobalt sulfate. Because then again, if this formula is wrong, I can look at your mass and figure out, well, they maybe wrote the formula wrong, but the mass is correct based on the formula that they did use. Now, sometimes they won't make you do every single element. So, for example, in this last one, we're just looking for the percent nitrogen in ammonium phosphate. So I do need the formula, ammonium phosphate. Ammonium, actually, they're both polyatomics. NH4 is ammonium plus 1. PO4 is my phosphate minus 3. Which means to make this neutral, I'll need 3 groups of ammonium. Then I should have a plus 3 minus 3. Now, the one thing that I do like about this is sometimes people make silly little mistakes when calculating their molar mass. Or, I guess for that matter, even in writing the formula. Make sure that you used phosphate, the polyatomic, not phosphide. Phosphide would just be regular phosphorus minus 3. Make sure that you have parentheses around the ammonium. You need 3 groups of NH4 so that when I find the mass, I will need to distribute the 3 groups of ammonium should give me 3 nitrogen and 12 hydrogen. Then there's only 1 phosphorus and 4 oxygen. So sometimes people will ask a question. The 3 on the outside of the parentheses, that gets distributed. But like this 4 here by oxygen, that is only for oxygen. If we have parentheses around our polyatomic, that's when we might need to multiply because we have multiple groups. Here I just have 1 group of phosphorus, and I should say 1 group of phosphorus and 4 oxygen atoms. So when I plug this in my calculator, I'm going to do this. I'm thinking nitrogen's mass is 14.01. I'm going to multiply by 3. Hydrogen is 1.01 times 12. There's only 1 phosphorus, 30.97 times 1, and there are 4 oxygen. 16 grams per oxygen. There are 4. That's what I'm going to plug in my calculator to get the molar mass. Now, you don't have to show me that work, but sometimes, like when there's multiple polyatomics and parentheses, that's when people make silly little boo-boos with their molar mass. You won't do that, of course. So if I add all this up, I'd be looking at 149.12 grams. Lovely. This is really all I would need to see. I would need to see percent nitrogen equals 3 times the mass of nitrogen. I want the total amount of nitrogen. So 3 times 14.01 is 42.03 grams of nitrogen. Divided by the mass of the compound, 149.12. Then show me the formula that you used. NH4, there are 3. PO4, ammonium phosphate. We'll multiply by 100 to make it a percent. All right, so maybe like 28.19% nitrogen. Awesome. Show me the work in red. I know that you multiplied nitrogen's mass times 3 because you want to use the total amount of nitrogen in the compound. I know that you have the right formula for the compound ammonium phosphate. I know you got the right molar mass, you did the right calculation. A+. This percent composition stuff, not so bad. You maybe practice a few, but it just makes sense.